In this video, we're going to be talking about surface area of cylinders and rectangular prisms. So the definition of surface area is the sum of all surfaces or faces of a three-dimensional figure. So remember that sum means that we're adding. So you're going to find the area of each part of the outer side of a figure and add all of those areas together to get the entire surface area. So some of the words that we hear when we're talking about surface area include cover, wrap, paint, surface, or square units. So you could talk about wrapping a present, painting the outside of a box, covering up covering a cylinder with a label, that kind of thing. So as a reminder, when we talk about just having a line, that's going to be measuring the length in just one unit. So it's a one-dimensional line. But then we get into 2 dimensions and we have a square or square unit. So this is a 1 by 1 square. So it's 1 square unit. This is when we talk about area or surface area, which is what we're focusing on this week. And then 1 cubic unit or cubic unit squared is a 1 by 1 by 1 cube. So that was when we talked about volume last week. So it's how much that object is filled with. So then we have some formulas that are going to be helpful here. So the area of a rectangle is length times width, so just one side times the other. For circles, the area equals pi r squared, so you multiply pi times the radius squared. Remember that radius is half of the diameter. To find the circumference, and remember that circumference is the outer edge of the circle, so the distance around it, you do 2 times pi times radius. To find the diameter, you multiply the radius by 2. And to find the radius, you would divide the diameter by 2. So these are just some of the formulas that might be helpful with the circle and the rectangle as you learn surface area. So when we talk about surface area of a rectangular prism, we're talking about all of the edges of this shape and adding up their individual areas. So for example, this is a net of a rectangular prism, and all a net is just the sides of this shape unfolded. So I'm going to open up this quick video link just to show you what the net of the rectangular prism looks like. So you can see here that there's your net, and they're going to fold in the sides, and that is how we can build that 3D figure of a rectangular prism. It's going to have 6 faces: the top, the bottom, the left and right sides, and the front and the back. And you can see all of those individually when it goes back to that 2D net shape. So these 3D figures are really made up of these different faces, and so we can find the area of each individual face and add it all together to get the entire surface area. So the surface area of our rectangular prisms, we're going to need to know the length, the width, and the height of the rectangular prism. And then to find the surface area, you have this purple section, which is your length times your width, and your length times your width. There's 2 of these purple sections, so we write it as length times width, but times 2 because there's 2 of them. And then we add that to 2 times length times height. So these length times height are these darker blue rectangles, so the length times the height, but there's 2 of them, so we do 2 times length times height. Plus, finally, the 2 times width times height, and that's our light blue triangle, or not triangles, the light blue rectangles that are on the left and right sides here. And so that's height times width, and there are 2 of them, so we say 2 times width times height. And all of this net folded up again is going to get us to that rectangular prism here. So then you have your left and your right side as the blue, the light blue. You have your front and back as that darker blue, and your top and bottom as purple. So that's the surface area for a rectangular prism. Remember to follow the order of operations. Multiply each of these 3 things together before you add them together. Then we can move into the surface area of a cylinder. And again, we're going to be looking at the net of this shape. So the net for this one has the top that is a circle, the bottom that is a circle, and then the edge, if you were to cut the side of a can open and unfold it, it would just become a rectangle. So these purple circles you can see are the 2 circles that represent the top and bottom. And to find the area of a circle, remember we said that is pi r squared. But we have 2 of them, so we say 2 pi r squared, and that's where the purple part of our formula comes from. Then we're trying to find the area of this rectangle. But it's not just length times width because we've got different dimensions here. The length of this rectangle is actually the circumference of our circle. So it was the distance that wrapped around this circle, because if you were going to fold this net back up, it would be that whole length around the circle, or its circumference. So we measure it as 2 pi r. Then we have the other side of our rectangle, which is our height. And so to get the area of this rectangle in here, we multiply 2 pi r, the circumference, by h, our height. And that's where the second part comes from. So you're really adding together two circles and a rectangle when you're finding the area of a cylinder. So you can imagine if this was a soup can, the two purple parts would be the aluminum lid and bottom of your can, and then the this rectangle around it would be the label that goes around the soup can. So to do these problems, you just need to use the formulas like we did with volume. However, it's really important to make sure that you're taking the time to write down your work and to follow the order of operations. So step 1 for solving surface area problems for rectangular prisms would be to look at your formula sheet and write your formula. And just for the sake of filling in the notes this week, I've filled those in for you for step 1. Step 2 says to replace the formula equation with the appropriate numbers, and step 3 says to solve and label with the correct unit of measure. So in our first example, we've got a rectangular prism. The length here is 10 centimeters, the width is 2 centimeters, and the height is 5 centimeters. So now we're going to use our formula, which is surface area equals 2 times length times width plus 2 times length times height plus 2 times width times height, and fill in all of our values for each of those. So surface area equals 2 times our length, which was 10, times our width, which was 2, plus 2 times our length, which was 10, and our height, which was 5, plus 2 times our width, which was 2, times the height, which was 5. So now what we've done is we're saying I'm going to calculate the area of the front, I'm going to calculate the area of the top, and I'm going to calculate the area of the side, but I'm multiplying each of those individual areas by 2 because there's a top and bottom that are the same, the front and back that are the same, and the two sides that are the same. So we're going to add up all of those areas, but before we can add, we have to multiply. So we're going to say 2 times 10 times 2. Well, 2 times 10 is 20, times another 2 is 40, plus 2 times 10 times 5, so 20 times 5 is 100, plus 2 times 2, which is 4 times 5, gets us 20. So these become our three values, and now all we have left is to add, so 40 plus 100 plus 20 gets us a total of 160 centimeters squared. And we're always going to be labeling our surface area problems with units squared, or with the unit that you have and then putting the superscript up there, or you can write it as square unit. It's up to you. If you want to pause and try this next one, you can. To review, the length is 7 inches, the width is 1 inch, and the height is 2 inches. So to fill in our formula here, our surface area equals 2 times the length of 7 times the width of 1, plus 2 times our length of 7 times our height of 2, plus 2 times our width of 1 times our height of 2. So that fills in our formula, and now we have to multiply before we can add. So 2 times 7 times 1 is 14, plus 2 times 7 times 2 gets us 28, and 2 times 1 times 2 will get us 4. So in our final step, we will say that our surface area is the three of these numbers added together for a total of 46 square inches. And so in this case, I'm going to label it as square inches. If you want to copy and paste the squared from up there and change the centimeters to inches, you can do that too. On our last page, solving surface area problems with cylinders, we have our three same steps. So you need to choose the correct formula, replace the formula with the appropriate numbers, and solve and label the correct unit of measure. So here in our cylinder, we're going to be finding the surface area. So remember, it's our outer edge, so it becomes a rectangle if you were to unfold it and see the net, plus the two circles from the top and the bottom. So we need to know the radius, which is 4 feet here, and our height of 12 feet. And we fill in our formula the same way we did before. So we have 2 times, and remember that we're going to be using pi as 3.14, times our radius, which is 4, and we're actually squaring it because it says radius squared, but as a reminder, to square a number, you're just multiplying it by itself, so I'm going to write that as 4 times 4. And then our next part of our formula says 2 times pi, so 3.14, times the radius times the height. So now this shows our whole formula. We've got a lot of math to do here, but mostly just multiplication and addition. So we need to multiply before we can add. So over here you might want to use your Desmos calculator, and I'm going to say 2 times 3.14 times 4 times 4, and that gets us 108 and 48 hundredths. And then we can add our next part, which is 2 times 3.14 times 4 times 12, which is 301 and 44 hundredths. And so then once we do that, we can add up for our total, which gets us a surface area of 401 and 92 hundredths feet squared. So the reason that there's this extra line here is because if you were planning to use the exponent, you could do it that way too. So the way I would have written it with the exponent would have been that I needed to square my radius here. So if you wanted to see it that way, this is what it would have looked like. And instead of our radius, we would write 4. Oops. And so then if you wanted to use Desmos using the exponent button, you're more than welcome to. So the other way you could have done this problem, you could have said 2 times 3.14 times 4, and then press that a squared button to square the 4, and then that still gets you that same part that I was showing you here. Or you could have said surface area equals 2 times 3.14 times, well, I know 4 squared is 16, so I'm just going to fill in that step, and then you could have done the rest of your multiplication in the following step. So there's lots of ways that you can solve these problems as long as you're following the order of operations and either doing your exponent first or just changing your exponent into multiplication. That's fine. So you can pause the video and try the next one on your own. The radius here was 15 inches and your height was 13 inches. So we're going to fill in our surface area formula. So you can say 2 times 3.14 for pi times your radius, which is 15, squared, and I'm going to add in my exponent like this, and then I have to add 2 times 3.14 times my radius of 15 times the height. And again, I'll make this a little bit smaller, and then you can use your Desmos calculator to help you figure this out. So what we're going to type in this time is 2 times 3.14. Type this in correctly. So 2 times 3.14 times 15, and you can hit the squared button, and that gets us a first value of 1,413. And then we need to add the second part of our formula, which is 2 times 3.14 times 15 times 13. Oops. And there's a common mistake that you can make, and I just made it. Instead of typing the X button, you need to actually hit the multiplication symbol, and I was getting lazy there and just pressing X. It does not work out because it thinks you're talking about a variable. So, good mistake to make there. So this part gets you 1,224 and 6/10. So then what we're going to do is just add those two values together to get our total surface area. And so we end up with a final surface area of 2,637 and 6/10. And remember that since we're talking about surface area, we want to put it in units squared. And in this case, we were talking about inches, so we can say inches squared or square inches. So you have lots of ways to label it as long as you're putting the correct unit of measure in there. Thanks for watching.